Hi, my name is Jennifer, and I'm going to show you how to subtract polynomials. So grab a pencil and some paper and work through these problems with me. Let's look at this first example. We have 2x plus 5y minus 3x minus 2y. This is a binomial minus a binomial. We are going to follow the same rules of subtraction that we did when we were subtracting integers. We are actually going to add the opposite of this binomial, and I'm going to show you how to do that. We are going to keep 2x plus 5 the same. We are going to take this subtraction sign. We're actually going to change it to an addition sign. Because we changed this to the opposite sign, we need to also change the opposite sign of 3x to a minus 3x, a negative 3x. And then we're going to change this minus 2y to a plus 2y. And now we're ready to solve the problem. We are going to add like terms. Okay, like terms mean if it has the same variable and the same exponent, we can add the number or the coefficient in front. So 2x plus a negative 3x is a negative 1x. 5y plus a positive 2y is a positive 7y. Now you can leave your answer like this, or you can write the problem without the coefficient of 1. You could say negative x plus 7y. Either answer would be fine. Okay, let's look at our next problem. This is a trinomial subtracting another trinomial. We have 7x squared minus x minus 4 subtract negative 2x squared plus 3x plus 5. We're going to go through the same process as we did the previous example. We are going to add the opposite of this second trinomial. So we're going to take this subtraction sign. We're going to make that a plus sign. But we're also going to change the opposite signs for each of these terms in this second trinomial. So instead of a negative 2x squared, we're going to have a positive. Instead of a positive 3x, it will become a negative. And instead of a positive 5, it will be a negative 5. And now we're ready to add like terms. We need to add the coefficients to each other, the ones that belong with the same variable and the same exponent. So we have 7x squared plus positive 2x squared, which gives us positive 9x squared. Next, we have a negative 1. Remember, there's a 1 coefficient if you don't see a number there. This is a negative 1x plus negative 3x, which makes a negative 4x. And for our constants, we have a negative 4 plus a negative 5, which gives us a negative 9. We put these individual terms in order, in descending order, and we have the trinomial 9x squared minus 4x minus 9 as your final answer. Okay, let's look at our last example. We have the trinomial x cubed minus 2x plus 3 minus the trinomial 3x squared plus 4x minus 5. We're going to apply the same rule with subtracting integers. We're going to add the opposite. We're going to change this subtraction sign to an addition sign. Then we will have to change the signs of the second trinomial to the opposite. Here we have a positive 3x squared. We're going to change that to a negative. We have a positive 4x. Well, change to a negative. And then we have a negative 5, and that changes to a positive 5. Now we're ready to collect like terms. This trinomial starts off with a 1x cubed. Now notice that there is not an x cubed in our second trinomial. Okay, so it does not have anything to add to. So we are going to go ahead and transfer the x cubed down to our answer line. Okay. Next, we have a minus 2x. However, we do have an x squared term here, and if we're following descending order, after the cubed, we need to put the x squared term. And so because there's nothing in this first trinomial to subtract that matches the x squared, think of it like 0 minus 3x squared, which gives us the value of minus 3x squared. Next, we're going to look at this minus 2x plus a negative 4x, gives us a negative 6x, plus a positive 3 plus a positive 5 is a positive 8. Okay, we do have our answer in descending order according to the exponents. And so our final answer is x cubed minus 3x squared minus 6x plus 8. Now, if you still have questions about this, contact your professor or stop by the Math Tutor Lab or replay this video again.